All right, now here we're doing another set of slides that are based on Blast. Now that you've actually seen it, um, I'd like to do a third Blast video here with you. So we did a basic Blast search, so you actually have something to reference now. So let's go through these slides very quickly. Of course, this is what Blast stands for, Basic Local Alignment Search Tool. Um, these are all the advantages, and it finds the pieces that are similar depending on where they are in the sequence. So there are many types of blast. We did blast in, but you could also do it with proteins. You could do blast X, which translates the proteins back into nucleotides and then compares it to other nucleotides and then back to proteins again. It's just slightly different. Takes a little longer, but it can do some things that the other blasts cannot do. Blast in is a similar kind of approach, using turning it into proteins, comparing all the proteins, and then giving you the proteins after you translate it. And then T Blast X is the ultimate. It takes the longest and gives you the most, I guess, the most sensitive results, or the most actually. No, it would give you broader results. Sorry, take that back. So it would find some things maybe the other blasts didn't. But as a general rule, if you're just interested in nucleotides, you'd stay here. If you're just interested in proteins, you do here. Now, if you're interested in very difficult things to find that aren't very similar to one another, and you're looking for very small sequences out of a very large sequence, and you're looking for those small parts that haven't changed. These three would be. We're probably not going to do much of this. We will do some of these, but for the most part, we will stick with these two. Um, Blast in. Homology, we've talked about homology, useful for finding common ancestors and things that are important because they don't change over evolutionary time, means that they're important. And then we can also look at the things that are not as important, the things that did change relatively easy in the sequence. Most of the time, you're interested in the parts that don't change, but you could be interested in the places that do change. The Blast P, of course, is for proteins. It's the same thing. All right, and this is just telling you about Blast X, where it converts from proteins to nucleotides for you in the query. And then here you're doing a little bit more converting back and forth. Like I said, we'll do this later. I just wanted to tell you about the different types at this point. That's what those would be for. You do need to know about the E values, the one we will use. Smaller is better, and it basically the 0 is perfect. You actually aren't learning much if it's 0. It means you found the exact sequence that you were looking for, that you already have, if it's 0. So you need to go to something that has some type of value, but 0 actually is just saying you found your identical sequence. You, of course, can get a list of alignments. We saw that. We also saw where I got the GenBank file and then also the FASTA file. Don't worry about the assembly. That's just basic large sequences that are this down here. We're not going to be using that, though it's useful if you're actually in the lab doing RNA type experiments. That would be interesting, but we're not going to talk about that. Let's see. You can also choose different databases. We were using all databases, but there are specific databases, like specific databases of just human, mouse, fly, Arabidopsis, and there are search engines for that. But we can choose that. We saw that if we just wanted to do mouse, we could choose that from the NCBI Blast. There are various differences, different blast sites. You could do just fly-based blast, which if you go there, you only get fly results. But they have lots of other information about flies. some of these others have specific additional information about that species if you go and use that blast. And that's it.